Okay, this example gives me a cumulative frequency diagram. It's to do with heights. We've got height on the axis. We've got girls and boys. Okay, there are 80 of each, and we've got to compare the heights. Now, trying to actually get the correct comparison of these graphs is quite tricky. People look at it and they say, okay, this line for girls is above the line for boys, so maybe girls are taller. What a load of rubbish. It's not true at all. Okay, the thing to do is to not try and interpret the diagram directly, but to get some measures from it. So we can get things like medians and quartiles. We can see that actually the shortest girl was 130, and that's the same as the shortest boy. And we've got the tallest girl and tallest boy both with the same height. So the actual extreme values at the ends of the range are the same for both. But the medians and the quartiles would be different. So the first thing we can do is what we did before, look for the medians and quartiles. And I've got an n of 80 in each sample. So if I look at my 80, then where am I going to find my median? At 40. So this is going to be my starting point for the median. And 3/4 and 1/4 of 80 are 60 for the upper quartile and 20 for the lower quartile. So I'm going to bang all of those lines on and see if we can get some medians and quartiles. I strongly recommend that you do this for yourself. We did this in the previous example. Put some lines on, see what happens. Okay, have you done that? Well, if you have, it should look like this. So we just got to read off our values. Okay, so for my girls, okay, my lower quartile is here. So Q1 equals, make that 149.5. Okay, your values may be very slightly different because using the ruler is is an estimation process, I suppose. So the median for the girls is going to be this value here, which is 157.5, and our Q3 is going to be this value here, which is 164.5. I've got my corresponding values for my boys, and I can work out the interquartile range each time. So I need to do 164.5 minus 149.5, which gives, what's that, 15? Okay, so what does it make sense to compare here? Well, I've got two medians. They're measures of centre, so I'm going to compare those. And my interquartile ranges are a measure of spread, so I'm going to compare those. So from the medians, what we can say is that we can say which group is, we've got to be in context, so we're talking about heights. So we're going to say which group have either seemed to be taller on average. Okay, so I'm in context because I'm using the word taller. That refers to heights, and I'm talking about boys and I'm talking about girls. But the other thing to note is I'm using weak language. Okay, I haven't proved that all the boys were taller than all the girls. Okay, they tended to be taller on average than the girls. There are certainly going to be some girls here who are taller than some of the boys. So don't word any conclusion in statistics too strongly. And then for the interquartile ranges, it's slightly easier to express a difference. Actually, these figures are so nearly the same, I almost don't want to say there is a difference. What I've said is the boys' heights were very slightly more varied than the girls, but the amounts of variation were very similar. Okay, so it's actually easier to make the first statement about the more variation in the boys' heights, but I actually wouldn't want to leave it there because really my drawing could have created this slight difference in results. So I'm happy with those conclusions. Notice it's in context because I'm talking about heights and I'm mentioning boys and I'm mentioning girls, okay, and I'm recognizing that this slight difference may actually not mean anything.